It's fine. It's about normal. So what we're looking at today is solving polynomial inequalities and solving rational inequalities. These inequalities are models and solved in real life. We're mainly going to look at solving inequalities. The zeros are the key numbers. So for any of these inequalities, finding the zeros where it crosses the x-axis is key. Where it crosses the x-axis is going to be key. Because wherever it crosses the x-axis, where it's a 0, is where the sign changes from positive to negative or negative to. So when we're talking about inequalities, these intervals, so this function here has zeros at negative 1 and 3. So if we're looking at values for where it's positive, we're looking for where the intervals are going to be if this was a two-dimensional graph up here, yes? Or possibly looking down here, yes? And this will make sense when we actually look at a problem, but the zeros are going to be key. Find all the key zeros. We'll go through this. Solve this here, then graph the solution set. So when we look at this here, what we want to find first is the zeros. Now I can find it using the quadratic formula, or I can factor, but let's go on and factor this. X minus 3 and x plus 2. We good with how that factored? Okay. So we have these two here, yes? Now, I'm not worried about the less than 0 right now. I want to see where the zeros are at, where it crosses. So here we'd have x minus 3 equals 0. So x is equal to 3, because we would add 3 to both sides. X. So we would subtract it and get negative 2, yes? We want a number line. We have negative 2 and 3, yes? These are the points where this graph changes from being positive to negative or negative to positive. It's going to change one or the other. Give me a number less than negative 2. Give me a number between negative 2 and 3. I like that one better, because 0 is easier to work with. Then over here we can have 5, 4, it doesn't matter. We pick one. Let's do 5. Now, what does this equation have to be? It has to be less than 0. So we have x squared, what is it, minus 3x minus 6? Minus x minus 6. Minus x minus 6 is less than 0. Now, the first number we said was, I'm going to plug it in, negative 3 squared minus negative 3 minus 6. Because negative 3 squared is positive 9. Negative and negative makes a 9 plus 3 is? Minus 6 is? Is this less than 0? No. So that means if this was a two-dimensional graph, the graph would be somewhere up here, yes? It would be greater than 0. The y values would be greater than 0, yes? Okay, well, that's not what we wanted. Let's try 0. 0 squared minus 0 minus 6. That's 0 minus 0 minus 6, which is, that didn't work. This one, because it's going to be somewhere down here. I'm not circling 0. I'm just saying it's down below 0. What do I know about 5? Where is it going to be? Because what is the degree of the function? It has to go back up, because this function, if we graphed it, would come down. It has to come back up. But if we do plug it in, 5 squared minus 5 minus 6. Well, 5 squared is minus 5 minus 6. 25 minus 5 is 20. Minus 6 is 14 that is not less than 0, correct? Okay. So I'm going to grab this parabola and move it down here. And erase all this here. Now, where was the interval that it worked? Between these two here, yes? Is it equal? Was it equal to either one of these 2 points? Keep it open. So the interval for which this works is -2 to 3. Because those are the values for x that will make this function work. And that's it. That's all we have to do for this here. Now you can also graph this on a graphing calculator to check. X squared minus x minus 6. We're not worried about this here. It would give us the graph. And we see that it'd make an intersection at -2, go down and come back up. Or is it less than 0? All these points down here. That's it. Questions on this here? Not too bad. We have this here. We have our test, so they picked points, -3, 0, 4. Test them. And we found out that's what it works. This is what the graph looks like. I see that it's less than 0 here. So those are the points that work. Questions on this here? Open your book to the homework on this section here.
Wait, gives the insights.
Oh.
Sorry.
So, this is one of the problems from the homework. And I'm doing this kind of help you out. Just be nice. So what we need to do is we need to find what it calls the key values, yes? The key values are our zeros. Because again, for any function of any quality, we need to see where is it turning from positive to negative or -2. That's what we want to find. Now, we could try graphing this. It could work out that graphing it will give us whole number answers. Let's just assume it's not. The only way I can add or subtract fractions is if the denominators are the what? Same. So I have to change 1 to have a denominator of x minus 5. So how could I make the denominator x minus 5? So the numerator would be what?
Or x minus 5.
Because I'm going to multiply the numerator and denominators to make them be the same. So here's just x minus 5. And because the denominators are the same, it means I can add the numerators. Well, x doesn't have any like terms. 1 plus -5 is -4. So the denominator tells me what? X cannot equal 5 because that is a vertical asymptote. X minus 4 tells me x is equal to, because 4 minus 4 would give me, how many key factors or key things do we have here? 2. Because one of them is 4, the other is actually 5. The other one's 5, and we'll see it, and I'll let you see it when we graph this. 4.5. What's a number I can pick less than 4? There's only one number I'm ever going to pick that's less than 4. If I can pick 0 as an option to check something, I'm always going to pick 0. Because anything times 0 is 0. It makes this thing easy to figure out. Okay. Are you? Okay. So we can check 0 first, because if I check 0, well, that's just 4 over 5. Is that greater than or equal to 0? Yes. This works. 4.5. This one will need a little bit more math. Because we'll have 4.5 minus 4 over 4.5 minus 5. 5 over negative, which is negative 6. It's 6 minus 4 over 6 minus 5. 2 over 1, which is 2. That works. So what intervals is this true on? Well, actually, we went too far. I'll tell you that right now. Because what did it, so reading the instructions, what does it say, Tori? Did it say to solve? Did it say to find what values of x makes the statement true? Did it tell us to graph it? What are the key terms? 4 and negative 5, or 4 and negative 5. And what you'll find is a lot of the asymptotes, I think you've graphed some of these already, yes? When we had a vertical asymptote, it normally did this, yes? On most of them, one direction it went up, the other direction went down. Same thing's going to be true here. So if you grab your graphing calculator and graph x minus 4 over x minus 5, at 5, it's either going to be doing, because again, it didn't work here, so it's going to be going down. It's going to be doing something like this here. So vertical asymptotes are key. I'm glad we did this one. Vertical asymptotes are key points, and x-intercepts are key points. So those are the two that we find, and it kind of helps us with. So vertical asymptotes are key. Horizontal asymptotes, not as much. But questions on this here? We good with this here? You want to see another one of these? So it will never equal 5 because the denominator would become 0. So we can't find that value. We can't find the exact value at 5. But we can actually find what it approaches. We can find out what it approaches. Okay? So this isn't mathematical. I mean, we can't actually divide by 0. There's nothing we can divide by 0. Okay? It would be the same thing as saying that x equals 5 is right where a cliff drops off. So if you actually walk to where x is equal to 5, you fall down into a hole, yes? But we can still find and get very, very close to the edge, close to where that point is, and see, okay, this is where it's leading. That's when we, in calculus, what we call taking limits, the limit of the function coming from left and right. We can take it from both directions and see, does this come at a point? Either both going down, both going up. What is this approaching? And taking a limit is coming to an approaching a point. So even though it doesn't exist at that point, we can still take the limit of it approaching that value and find out what it is. Does that make sense? And that's calculus stuff. So that's nothing, unless you go take calculus, then it'll get more in depth and it'll explain it better, okay? And that's dealing some with rational inequalities, okay? Any questions on this here so far? So like number 9, where it's x squared? Yeah. X squared minus 3x minus 18, there's nothing on top and bottom. Our key points are only going to be the intercepts because we won't have vertical asymptotes in a quadratic or a polynomial function. So we good with these here so far? Yes?
Yeah.
I think 13 was one of the ones. X squared plus 4x is, and this one here we want to graph it.
Solve the inequality and then graph the solutions.
Yep. So to solve it, I need to find the zeros because I need to find the key points. Is there, hey, look, steps, greatest common factor.
Yes, the greatest common factor to x.
Which leaves us with x plus 2. So for this here, 2x is 0, so x is 0. X plus 2 is equal to 0, so x is -2. Well, this isn't fun. Why? 0 is a point, yes? Can I use 0 to check?
No.
No. -1. Hold up. Math hypocrisy. Needs to be this way. Because we need, say, -3, -1, and 1. I'm just picking 3 values in between it. I want to try to keep them whole numbers because decimals aren't as nice. If I can avoid a decimal, I'm going to avoid one. If I have to have a decimal, I normally do halves. So as we saw in the last one, -4.5. Do halves. Because the farther away from halves, quarters, they don't work as well. They'll get you the correct answer, but they're harder to work out unless you have a calculator. So I'm going to erase this here so we can check. So -3 will be 2 times -3 times -3 plus 1. 2 times -3 is? Which is that less than 0? No. -1. What's -1 plus 1? This whole thing is? Oh. Knew that didn't look right. What is our actual one? It'd be -1 plus what? -2 times.
Oh, okay. Yes.
Okay. I'm going to take you through my thought process. Because I stared at that, as you noticed or heard, pretty decently. Because remember back to one of our previous lessons, we had turning points, yes? I have 2 intersections, yes? And it is a quadratic, so it's degree 2. So that means both sides, since it's even, have to either both be going up or both be going down. They have to be going in the same direction. So since this side here is not less than 0, that means the function is somewhere up here, yes? This is 0. It's turning from positive to negative. We already know that this side is positive, yes? So if I had written it correctly and we got that this was wrong, it meant that this here had to turn at this point and go back to positive. Had to go back to being positive and then come back down here. But if it's doing that, that means the number of turns is greater than, well, we've got 1, 2. Well, how many can I have? It's degree 2. I can only have 1. It has to come back down. It has to cross here. So that's what I was seeing. That's what I was thinking because I'm like, okay, if this doesn't work, it means it has to go back up. But because it's degree 2, it can't turn like that. If it was degree 4, it can have 3 turning points, because that's what I was thinking. Maybe it's degree 4, then it can come up, it can come back down at 0 and go back up. But it's not doing that. It's degree 2. It can only have 1 turning point. So that means it has to come down here and go back up here. And as we saw, it does work. Which means this one over here doesn't. And if we did check it, 2 times 1 is 2. 1 plus 2 is 3. 6, it's greater than 0, it does not work. Questions on this here? If you're getting stuck on these, graph them, graph them, graph them, graph them. Less than 0, we're seeing where is it below the line. Oh, the graph's below the line here. Those are the points that work, and it's between -2 and 0. That's it. Questions on this here? We good with this here? Is this making sense? These easier than you thought they'd be? Yes? Huh? Let's do another one. Grab another one. Because that's normally where I grab them. Grab the one that looks the hardest. 17 is actually not that bad. 30. 30 is what?
2x squared cubed plus 30.
What? 2x cubed.
Minus 8x.
Because I was about to say, I'm like 2x to the 6th. So your power squared, yep, that multiplied. So when we look at this here, if say this had been an equal sign, this is a polynomial function, yes? That's the first thing we do on any polynomial function. We get everything on the same side. I want it equal to 0. Yes. Now the question might arise, or normally is, when I'm thinking about these is, and the first time, a lot of times you come across these is, doing this would this change the function? What we're talking about? Yes. It's taking this, all those ones with x, and moving them all down 52. But, so we're moving it all down 52. But we're also moving where it's greater than down 52. So this equation would have been up 52, but now we brought it down 52. But we also brought both sides down 52. It's not changing the zeros, it's changing how it looks. Does that make sense? Now with most of these here, when solving polynomial functions or inequalities or any of this here, this is a big warning, especially if you go into upper level math. Do not divide by variables. Do not divide by variables. Because when we divide both sides by a variable, it cancels out, yes? One of your solutions would cancel out. It'd be the equivalent of saying, you're trying to pick out shoes for a day. Okay, I've got 4 pairs of shoes. First pair I don't want anymore. You set it to the side. Then you look back at the remaining 3. How many sets of shoes do you have? 4 still, yes? But what did you do with 1 pair? You set them away, yes? But for us, looking at pairs of shoes is very easy to say, okay, they're right there. I still have 4 pairs, yes? With math, essentially when you divide by a variable, you're doing just that. You're setting it to the side. And as soon as you set it to the side, you're not solving it for it anymore. But you need all of them. You still need all of them. So that's why when we factor out variables, we don't divide. We don't eliminate them. Because that variable still has a value of x, which would make the function 0. We can't get rid of it. Because most of the time when we factor it out like the last one, or the one before, it came out x equals 0, yes? That's a key term, isn't it? I could have divided both sides by x, and it would have worked, but I would have lost that key term. Do you see that? They never really specify it. I think I may have specified it in Algebra 2. We don't do that, but that's why we don't do that. I just want to make that clear. Now this here, you can graph it if you want. We can graph this. And if we graph it, it would give us the zeros. It would give us the value of x for which this thing crosses. And we can look at it and see, where is it greater than 0? Where is it above the x-axis? Those points would work. Where is it below it? Those points would work. Now doing this by hand, I do it by grouping. When I have 4 terms and I don't have any of the zeros, I group it. These and these. Now, sometimes it doesn't work this way. Sometimes you have to mix them up. But normally it works like this here. Because when I look at these first two, x squared is all they have in common. So that leaves me with 2x plus 13. What can I pull out of 8x, negative 8x, to make it 2x? Negative 52 divided by negative 4. Four times 13 is 52. I do that because, hey, look, they both share something in common. They both share 2x plus 13. So we can factor that out of both, which leaves us with x squared minus 4. Here, so one way that you can get these a little bit faster is thinking about what we're doing. So if I want to move the 13, I subtract. So negative 13 divided by the number in front of x, which is negative 13 over 2. So I move it to the other side, because since it's negative, it comes over as positive. So 4, square root of 4 is, and we always have plus or. So the smallest number is going to be negative 13 over 2. So that's 6 1/2. Then we have negative 2. Then we have 2. So you can say negative 7, negative 3, 0, 3.
Freshmen and sophomores, that's all freshmen and sophomores, please report to the Hornet Arena. All freshmen and sophomores, please report to the Hornet Arena at this time. Also, the seniors will have a meeting today during flex in Miss Benja's room. Thank you.
So we're going to check these here. So we need to check all 4 points, okay? So negative 7. I'm going to skip some steps here so we don't have to write everything out. 2 times negative 7 plus 13 is negative 1. And then we get 7 squared is 49. Minus 4 is, so it gives us negative, that's not, it's not greater than 0. Then we do negative 3. Now with these here, you don't have to do them by hand. So you can type in the calculator, parentheses 2 times negative 3, which is negative 6, plus 13 is 7. You get 7 plus 6 is 13. 3 squared is 9. 9 minus 4 is 5. This works. That one works. 0. Well, 0 is nice because it would be 13 times negative 4. Okay, that doesn't work. Positive times a negative is going to be a negative. 3. Positive. Far enough. Here. So it works because we can see that they're both positive. You can type in a calculator, get the exact answer. I'm skipping steps because, again, we're running short on time. But it works, yes? Now, the way we write the answer is going to depend on the course that you take. Now, because it's equal to, I don't use parentheses. Brackets. Yes, find a safe space. I would not put it at the door. Put it on the other side of that bookshelf. The big U stands for union. Or we're combining them. Because the union, where you unite two things are shared, we share these two. If you flip it upside down, it's the intersection. The intersection where these two cross. And it's almost another way to think about it. When it's up, we're filling it in. Upside down, we're covering something up. Does that make sense? You could also say this and this. Or it's this and that. I mean, there's different ways to write it. But these are kind of the two. Does that make sense? And it depends on the professor, how they want it written. Okay? Questions on this here? Now, this is the first one where we had more than one that worked. Yes? Because we have two. Because up to this point, we only have one. But this works. So what that means is, here, if we look at a graph, I'm not going to do the y-axis, but we could have a function. This here, 4th degree or above, and it wants it to be greater than or equal to 0. So what interval would that be? It would be everything, because all of it is greater than or equal to 0. Yes? Now, this, yes. Okay. Let's just call this A and B. If it's just wanting greater than, or coming from the left, it'd be negative infinity, comma, A at the union of A, comma, B at the union of B, comma, because, can it be equal to 0? Yes. No. So the points of where it's 0 are not included, but because everything else is greater than 0, it works. So we have to exclude those points. Some might say this here. Or they might combine those as A, comma, B. Essentially what that's saying is all real numbers except A and B, except these numbers here. So it's some of the shorthand. But again, most high school level stuff would be the top one. That there is more college-based stuff. Upper level math stuff, you probably, even in some of the upper level math classes you take, college algebra, it's probably going to say the top one. When you get above that, you'd get this here. Okay? That's more proof-based stuff. But we'll finish this up tomorrow.